If your hands are not too busy, please give a round of applause as Hezekiah Suleman comes up to talk about introduction to blockchain. Thank you.
So today, very quickly, we'll be talking on an introduction to blockchain. Before we start, can we make it a bit lively? So when I say Web3, you say Lagos. Is that fine? All right. Are we together? All right. Web3. Hope it's not looking like a political campaign. All right. So we'll quickly talk about introduction to blockchain. Now, this is a very interesting topic. Whether you are a newbie or you have spent quite some time in the Web3 ecosystem already, it always comes, even while I was working on the slides, it came to me as something new. Not really new. I've been in this space since 2017, and but it just gets interesting when you're learning about the technology called blockchain. So we'll just decipher what the blockchain is all about. This is a foundational topic, and it will help you, improve on other aspects while you are doing the course of the conference. So let's have the next slide, please. Thank you. All right. Now, the term blockchain is basically a compound word. I'm trying to give us a background of what or how the word blockchain came about. It is a compound word stemming from two words, block and chain. Now, when you talk about blocks, just think of it as anything. It could even be a building block, any material. Just think of it that way. In this case, for the purpose of this teaching, we'll be having a block as a notebook. Are we together? A blockchain as a notebook. Is that fine? All right. Now, the blockchain is a compound word, right? So, the blockchain is a compound word derived from block and chain. Now, let's talk about what a block is. How many of us, I believe, I don't want to mention that, but I believe everybody attended a secondary school year, right? Are we together? Great. Now, in secondary school, there is something that a teacher does, and there is something that the students do. A teacher may come up stage to either dictate a note or copy it on the board, and then everybody copies it into their notebooks. Am I right? Am I right? Yes. That process is very similar to what happens on the blockchain. What did I say? It is what? Very similar to what happens on the blockchain. Now, this illustration which I made here just shows each of these blocks you can see, each of these colored blocks represent a block. And the link in between them represents the chain. So this is what technically happens, on the blockchain. A block is connected by a link of chains to another block. Block 1 is connected to block 2, block 2 is connected to block 3, block 3 is connected to block 4, to 5, and like that. Infinitesimally, right? Until maybe the blockchain gets, filled up or something. I don't know. So that's basically just what happens on the blockchain. Is that clear? All right. So let's have the next slide. All right. Now, a blockchain is like a digital notebook. Remember, I was trying to give an example of you have a notebook in secondary school. The teacher writes on the board or dictates a note, and then you copy it into your note. That's just how the blockchain works. Now, it is a digital notebook that is shared with everyone. In this case now, how does it work? Can I have a note? Does anybody have a note close by so I can quickly use to illustrate? Is there any book? Yeah, I think that works. Please. Thank you. All right, thank you very much. Now, can we all see this? Can we all see this? All right, this is a book. Take this as a blockchain. Each page in this book is a block. What did I say? Each page in this book is what? A block. Remember, all the pages in this book are interconnected. Am I right? When you're done with page 1, you move on to what? When you're done with page 2, you move on to what? until the whole note is what? Exhausted. So take the blockchain as a digital notebook. The blockchain is actually a digital notebook. What do you write in a notebook? You could write anything. That's the same way it works on the blockchain too. So on the blockchain, you can write anything. But most times, and what's most familiar with every one of us is transactions, right? So transactions are basically what are entered into every page or every note of the blockchain. Is that noted? All right. So the pages contained in that book are called what? Are we following? So the pages contained in that notebook are called what? The blocks. It's very simple as that. So the combination of those blocks all linked together is what is known as a blockchain. I believe that's very, very much simple enough. Another thing you need to know about the blockchain is that once any data is entered into it, once any record is entered into it, it cannot be altered. That is what makes it a blockchain. Remember, it's not only a blockchain that makes use of what? A ledger. Some of you might have come across this definition that a blockchain is a distributed and decentralized ledger, because those two features are categorically what makes a ledger a blockchain. There are different kinds of ledgers. For time, we might not be able to expatiate on each of them, but I'll just mention them. There are different kinds of ledger. There are centralized ledgers. For instance, the ones, in fact, when you start the classification from digital and non-digital, for digital ledgers, we have ledgers like blockchain, right? For non-digital ledgers, when you walk into a bank, like it used to be a thing back in the days that when you walk into a bank, after you've made a transaction, maybe you made a deposit to somebody or transferred money to somebody, that's manually, they give you a deposit slip. Am I right? They give you that check to confirm that their transaction actually went through. And then when you get that check, that piece of paper, you now enter the records, the date you made the transaction, the amount you made, then you sign at the end, something like that. How many of us have witnessed something like that? All right, great. So that is a non-digital ledger. However, in the case of a blockchain, the blockchain is a digital ledger, meaning everything you do has to be, digital, right? Great. So now, what makes it categorically a blockchain must be that it has the feature of being distributed, meaning that's what I explained here. First, it is shared with everyone. That means not one person has a single control over it. So when you make a transaction on the Ethereum blockchain, for instance, it is visible to anybody all across the globe. It even makes it easier if I have an ENS name, if I have an ENS domain name. For instance, if I am having hk.eth, once you go on the Blockchain Explorer, you just search hk.eth, you're going to see a list of probably all the transactions I made in the last 24 hours or, as far as you want to check, right? So everybody has some form of equal access to view whatever is being done on the chain. Is that correct? Great. So that is one of the characteristics, that distributed part of it is one of the characteristics of what makes it a blockchain. And it has to be decentralized, meaning it's not under the singular control of any central authority, for instance, the government. If it's under the control of a central authority, it cannot be called, sometimes people may call it a blockchain, but it's actually not a blockchain. It could be just a ledger. There are different kinds of ledgers. In fact, the term blockchain is derived from a technology which is a general, broad term technology which is known as distributed ledger technology, DLT. Are we together? Hope this is not confusing. All right, so it's gotten from the general broad term which is known as distributed ledger technology. So for that, we have different kinds. For instance, CBDCs. How many of us have heard of central bank digital currencies? Yes, quite a sizable number of us. Nigeria has what? A CBDC, even though, I don't know, I'm not so sure if it's in use, right? And different other countries all around the world have CBDCs. Now, CBDCs too are built on a ledger, right? They are built on a ledger, different kinds of, like I said, there are different kinds of ledger. They are actually built using a technology very similar to blockchain technology, but the difference, that it makes is that most CBDCs are not decentralized. Are we together? They are under the control of a central authority, which is the central bank of that country. Is that noted? Is that clear? Great. But for you to term or to name something, that technology, blockchain, it has to be decentralized and distributed. So basically, that's just what we are trying to explain on that slide. So now the next slide. What is a block? Remember, I told you there are basically two terms or two words which form that compound term blockchain: a block and a chain. Now, on a page, you may see, if you are probably very detailed enough to maybe want to count or something like that, you may just count, okay, that there are maybe 10 lines on a page, right, that you can write on, 10 different lines, something like that, right? So each of those lines can take, let's say, on that page, let's assume there are 20 lines. So it can only take 20 lines of word. Are we together? That's the same thing that happens to on the blockchain. Every block, which I'm referring to now as a page, every block has a maximum number of transactions it can accept. What is contained in a block? Transactions. What is contained in a block? What is contained in a block? As simple as that. And every block has a maximum number of transactions it can accept. For some blockchains, it could be 8 number of transactions. So once 8 number of transactions are exceeded, a new block is created. Do you understand what I'm saying? So let me explain it. Now, this block 1, just as this illustration says, block 1, block 2, and block 3, block 4. Now, these are the constituents of a block, transactions. So let's assume transaction 1, Ade made a transfer of $100 to Nifemi. That's transaction 1. Transaction 2, somebody made a transaction to another person. It could be a financial transaction. Mind you, not on the blockchain, any kind of transaction could be made. As far as it's a transaction, it can be made on the blockchain, not just financial transactions alone. However, financial transactions were the first practical application of the usage of blockchain technology. So that's why it's like the most popular. Are we together? Great. So transaction 3, transaction 4, transaction 5, transaction 6, transaction 7. So in this case, we are assuming that this block can only take a maximum of 7 transactions. Are we still together? Great. We are assuming that this particular block, can only take a maximum of 7 transactions. So once this is exceeded, once we've gotten to 7 transactions, what happens next is that a new block is created. So on block 1, when we have 7 transactions, it moves to block 2, a new block is created. Once we have 7 transactions here, a new block is created. Once we have 7 transactions here, a new block is created, and it continues that way. Are we still together? All right, hope this is not boring. All right, so it continues that way, and the blockchain keeps running. Are we still together? Now, the first block on a blockchain is known as Genesis block. So whenever you see Genesis block, you don't have to be confused. It's still referring to the first block which was created on that chain. Is known as a Genesis block. And then we have the next block, the next block, the next block, and it keeps running that way. Are we still together? Now, like I also mentioned in this slide, a block could hold information. It holds information basically like transactions. It could be records. On top of records, it could be any kind of records, really. It could be health records. It could be logistics. It could be really anything as far as the record it can get on the blockchain, or data. Right? Now, each block connects to the previous one. That's just basically what I explained now, forming a chain. All the blocks in a blockchain are all interconnected. The first one is connected to the second is connected to the third, and like that. They are all interconnected. And this is actually what makes it a chain, because that chain cannot, be broken. Every transaction is always linked to another. You can track a particular transaction from the preceding transaction, and you can track a particular transaction from the transaction after it. Are we together? As far as a block has been created for it. So this way, why is this necessary? Why is it necessary that each of those transactions are linked to one another? Why is this necessary? That's what it answers here. That this way, no one can can change a page without changing all the data in the previous entry. So a blockchain cannot be manipulated. That's what brings it to that feature. We would also talk about the features of the blockchain, known as immutability. You cannot change what has been imputed on the blockchain, since they are all linked together. Now, I also wanted to give an example of traditional ways of recording data, in a centralized system, for instance. Now, let's take a university, for instance. Let's assume University of Lagos. Now, University of Lagos actually has a way through which they have, centralized servers where they store records of all students. So even if somebody graduated in 1978, for instance, the person can still come back to the university, the admissions and records office, or the records office, to say, I want to get this data, I want to get even if you forgot your matric number, you can ask them and they are going to provide it. So how do they do that? They actually store data. So data has been, in existence for ages. Data has been stored in different forms for ages, right? The only thing is that a blockchain makes it easier. It makes it simplified, right? It's just a simplified way of storing data, and in that way, nobody can manipulate it. Nobody can tamper with it because it remains safe, as long as that blockchain exists. So no one can change a page and like that, right? Now, let's talk about the key features of a blockchain. I already mentioned immutability, so let's first talk about transparency. Now, transparency, everyone can see what's happening on the blockchain. Am I right? How many of us have used the Blockchain Explorer? Okay, great, quite a sizable number of us. So, on a Blockchain Explorer, let's take Etherscan for instance, etherscan.io, right? When you go to Etherscan, you're going to see a list of all the transactions that have ever occurred on the Ethereum blockchain from its inception since 2014, right? You're going to see the Genesis block if you have the time to keep scrolling and scrolling and scrolling and scrolling until you get to the Genesis block. So you're going to see all the transactions that have ever been recorded on the Ethereum blockchain from its inception till date, till the transaction that is made right at this second while we are talking. Do you understand? Now, every block I told you has a numbering, right? I think on the Ethereum blockchain, the current block number, I've not checked recently to be honest, but the current block number should be over 8 million. That means over 8 million blocks have been created, starting from the Genesis block, 1, block 2, block 3, block 4, block 5, block 6, and we're almost, since 2014, we're almost at, it should be well more than 8 million already, if I'm not mistaken, right? So, it keeps counting it that way. Are we together? So it's transparent. Everybody can see, okay, block 1 has been executed. We are now at block 2. We are now at block 3. We are now at block 4 until, where you are. So every single process on the blockchain is completely transparent. Like I said, you can even check somebody else's transaction, right? If you probably know the person's ENS name or something, you can check the transaction the person made. So it's transparent. You don't need to probably go through any third party to be able to find out any detail you want to do, right? So everything is transparent, and that's why we even have smart contract auditors that, you could just wake up and say you want to be a smart contract auditor, try to check out things, do your own research and find out information about maybe a particular transaction. Maybe a particular transaction was malicious and you are trying to find out the root cause. It's something anybody can do, right? You just have to probably have the skill set and you get on it, and it's done that way. Now, immutability. Once something is written, it cannot be changed. That's simply what immutability means. So once a record has been entered into the blockchain, even if it was a mistaken record, it cannot be altered. That's why you must have heard by now that if you send a transaction, let's say it could be a monetary transaction. Let's say you sent $100 to somebody and you don't know the person. Maybe you made a mistake in the person's address. If you don't know the person, it's almost impossible to retrieve that money back, right? Or if you send that money into a contract address, right? A contract address is basically a special kind of address created that is not an EOA, it's not an externally owned address. So it's a special kind of address that is attached to a token to identify that token. Sometimes it looks like a wallet address, so some people might mistake it for a wallet address. But if you mistakenly send your funds there, they are there, except probably that address had a clause, maybe while the programmer was writing the code to maybe send out any token that was sent in there, or else that token is gone, right? So that's one advantage. It's an advantage, and sometimes too it could be a disadvantage, but it's more advantageous because once something has been entered into the blockchain, it cannot be altered. Is that great? Is that clear? All right, now no single person, decentralization, no single person or entity controls the blockchain. For instance, Ethereum blockchain. Who owns Ethereum blockchain? We all own Ethereum blockchain. Are you surprised? Are you surprised? Everybody here owns, and everybody by extension in the whole world owns, nobody owns Ethereum blockchain. People only built it. Ethereum is completely open source. That means anybody, if you are here today, if you have the skill set, you can just wake up, go to ethereum.org, contribute some, could be whatever you want to contribute to their code. Maybe you are a protocol engineer or something like that. You can contribute, right? It's completely open source, Ethereum is completely open source. So everybody owns Ethereum. Everybody owns a piece of Ethereum, right? Are we still together? Great. So no single person controls the blockchain. For it to be termed as a blockchain, if you term that technology as blockchain, that means it has to have that feature of no single person being able to control it. Are we still together? All right. Now, why is the use of a blockchain necessary? To everything that happens, there has to be a why. Why is the use of the blockchain necessary? Number one is trust. The first thing that led to the emergence of blockchain technology was basically trust. Now, I shared this example at Web3 Lagos last year because I was privileged to also speak on the similar topic, introduction to blockchain. Now, how many of us have used, let's say, Western Union to send money? Is there anybody like that? Anybody? Or probably you've received money through Western Union. You notice that there are two major issues with Western Union, except they've improved recently. Number one is that your transactions will not get to you in time. Are we together? It may take maybe 3 days to process or sometimes up to a week. And apart from that, the fees charged are super, super high. So maybe on a transaction of $100, you may end up paying maybe $15 as transaction fee. So those pre-existing systems, which are even still existing till date, was part of what prompted people to go into research on how we can create an alternative means for transactions, for payment, hence the emergence of blockchain technology. So now you just get on any blockchain of your choice, let's say Binance Smart Chain or Ethereum or any of them, and you just make a transaction and you are charged probably less than $100 transaction fee, and less than $1 as a transaction fee, and what else again? It gets to the recipient almost instantly. At least there are, in fact, most blockchains are super, super fast. It's just it's just a few of them that are not as fast, and we'll still talk about some of those issues, which number one of them is scalability. Are we still together? Great. So so now on the blockchain, people can trust. I mean, once I have your address, I can just send you a transaction. I don't have to bother because I know it gets to you. There's no intermediary to say, okay, somebody was supposed to deliver it to this person and it didn't get to the person. There's nothing like that. I mean, once I have your address, it's just P2P, it's peer-to-peer, right? That's what Bitcoin was originally designed for, right? To serve as a P2P payment system, a peer-to-peer, just from me to you. There's no intermediary, there's no Western Union, there's no MoneyGram, and such. So now, security. Now, the security part of the blockchain is one of the key features of the blockchain. The blockchain is super, super secured. Meaning, if I want to send a transaction from myself to a person, for instance, there is no fear that the transaction is going to get hooked somewhere. I mean, the transaction gets to the person for which it is intended, except you made a mistake on your part of copying a wrong address. Do we understand what I'm saying? Are we still here? All right. So the security is, since everyone has a copy of the blockchain, it's very hard for hackers to alter the information. Whatever information has been imputed on the blockchain, it's almost impossible for any hacker to penetrate it, right? You can't alter the information. You cannot change it. If you wrote ABCD, even if you used a particular kind of font to write it, that's still what remains. Nobody can alter that particular information which you have imputed on the blockchain as far as it is confirmed I would also talk a bit about that too. Now, let me quickly just diverge a bit before coming here. Now, on the blockchain, remember I told you the constituent of every block is what? Great, transactions. So I'm happy if you people, I mean, maybe everybody is following, so I'm happy. Now, every block, what is contained in every block are what? Transactions, right? Now, every transaction has a kind of unique identification. What did I say? A unique identification, which is basically known as a transaction hash. No two transaction hashes are the same. Now, have you ever seen some form of alphanumeric characters? Let's say you interacted with Ethereum blockchain, for instance, and you see some form of alphanumeric, string of characters. Let's say A, let's say OX, 0x, Y, M, blah, 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 blah. Maybe about 32 in number or something like that. So now, that is generated once any transaction is carried out on the blockchain, and it is unique. No two transaction hashes are the same. It is unique. So whenever you search that, the particular transaction attached to that transaction hash pops out. And when it pops out, what are the details attached to it? Number one, you have what's called a timestamp. What did I say? A timestamp. So you have a timestamp attached to it, meaning the exact day, time, minute, second, millisecond in which a transaction, was approved, or in which that transaction was sent. So sometimes you can even have 2 or 5 transactions within a second, within a particular second, sent within a second. Are we together? Sometimes you may see a transaction. This transaction was sent maybe 3:00. That's 3 o'clock now. 3:00:54, meaning it was sent at 3 o'clock 54 seconds. Are we together? You may see a transaction, maybe like 5 transactions like that, but there would still be some form of difference, maybe in milliseconds or nanoseconds between each of those transactions. However, on the blockchain, how a transaction is counted is basically in seconds. A transaction is counted in seconds. So we have what's known as TPS, transactions per second. Are we still together? Transactions per second. So every system of processing actually has a TPS. Whether it's a blockchain, as far as it's processing transactions, every system of processing actually has a transaction. It's like an SI value or SI unit of measuring the transactions which are made on the chain or whatever. Even Visa has, I think Visa currently is probably the fastest payment processor in the whole world. Whether it's centralized or decentralized, I think followed by Ton blockchain, right? Even though recently Ton blockchain has been, much more congested because of the number of transactions. We are still going to talk about that, congestion on the blockchain. So Visa is super fast. I think I really can't remember, but they have a very high TPS. So every processing system could have maybe a TPS of 8 transactions per second, which is actually very low. Some could have as much as 100 transactions per second. That means in every second, 100 transactions will be processed. Do you understand? So the lower a TPS, the lower the transactions per second for a blockchain, the slower the blockchain is going to be, right? So the TPS on Ethereum is not the same TPS with Bitcoin, for instance, or it's not the same with Solana, or it's not the same with Zcash, right? The slower or the higher the number of transactions that blockchain can process per second, the faster it's going to be. Are we still together? All right, now that leads us to scalability. I'll talk about scalability before going back to my slide. Now, what do you mean by scalability? When you say something is scalable, it means it is efficient. When you say something is scalable, it means it is efficient. That means, and when you talk about efficiency, you are talking about work rate. That means, what can you do within a specified period of time? So, if let's use myself as an example. If in, let's say 1 hour, I can stack all the chairs here in 1 hour, and somebody in 50 minutes can also stack all the chairs here. Are we following? The person is said to be more efficient than I am. Are we together? So that's also what is known as scalability. The person is doing the work at a more scalable rate than I am. Are we together? Now, what leads to scalability? Scalability is one of the most widely discussed topics in blockchain and within the Web3 ecosystem. So it's good that you understand it because you're going to be talking about it in subsequent talks from now. Now, what is scalability? Scalability is simply how efficient a blockchain is. So, for instance, what leads to scalability issues is it basically comes from congestion on the blockchain. Remember, I mentioned that more recently the Ton and blockchain has been kind of getting sometimes transactions are processed slower than it used to be initially. Are we together? Right? Great. So what led to that, or what leads to that, is basically the number of users on the blockchain. If, let's say, 1 million people are trying to make a transaction in 1 second, and that particular blockchain is designed to only handle 500,000 transactions in 1 second, what do you think we'll do? Can anybody answer that? Can anybody? I have a prize for the person. Let me go over the question again. If a blockchain is designed, by design, you have to specify what your blockchain can handle, maybe based on the kind of capabilities you want to equip it with, right? Like I said, not all blockchains have the same TPS. That means they can't all handle the same number of transactions per second. So if a blockchain is designed to handle 500,000 transactions in a second, and in that particular second, 1 million transactions were sent, what do you think will happen to, Yeah, please celebrate him as he comes forward.
I think it would handle the ones with higher gas or the
Celebrate him once again. He's on the way, but the answer is actually very simple. Okay, somebody wants to answer. Yes, I just want a particular word, just a word. Yeah, please. I appreciate him. All right.
If the blockchain is designed for 500, but I think the network will be congested. Then 500 for example says, because the other one will be today.
Set him. Okay, so let me reiterate what he said. He said, the word I just wanted to get was that the rest of the transactions will be pending. Have you ever seen pending on a particular blockchain? You see that maybe you sent a transaction and the person told you did not receive it, then you just took the transaction hash to it, let's say Etherscan for instance, and you just search it and then you see pending, right? That's just what happens. That means at that instance, there were too many transactions which made the blockchain congested. So it was the transactions at that instance were beyond the number of transactions that blockchain could handle per second. So what he said was, if the blockchain is designed for 500,000 transactions and 1 million that's 500,000 transactions per second, and 1 million was sent in that second, what happens is that 500,000 will actually be processed. Are we together? And they will be confirmed successful on the blockchain. However, the leftover 500,000 will be what? Pending. Are we together? So basically, that's just what happens on the blockchain. So this makes it easier. So sometimes when you see a transaction pending and you are wondering, you've already gotten the answer that at that moment, the blockchain could not handle more than the specified TPS. That's what makes transactions to pend. Now, let me go back to my slide. I believe I've talked about that. So please, I would like to meet with you, please, after my session for your gift. So another use of blockchain is security. Okay, I think I talked about that, and efficiency, which is also known as scalability. Now, real-life use cases of blockchain, the most obvious use case is cryptocurrency, with Bitcoin being the first cryptocurrency. So basically, they just help you send and receive digital assets or currencies, right? In a cryptographic form. Because sometimes too, I'd have loved to talk about cryptography a bit, but for time. But the blockchain, or most especially in the use of cryptocurrencies, the blockchain makes use of, even the entire blockchain actually makes use of a technology known as cryptography. You cannot talk about blockchain without cryptography. Cryptography is simply the art of encrypting and decrypting information. As simple as that. So when you encrypt an information so that another person does not know what is contained in that information, you are encrypting it, and decrypting it means trying to reveal what is contained in that information. That's why all transactions on the blockchain are encrypted. All transactions, in fact, all data on the blockchain are encrypted. A transaction hash is encrypted because you cannot just, if you make a transaction, it has to have a link, a unique ID. That unique ID is in an encrypted format, right? Is in an encrypted. If you just see a transaction hash, you cannot know what it means except you go to search it on the Blockchain Explorer. So it is encrypted. Blockchains are also used in supply chain, trying to track products. Maybe you sent something through Amazon or DHL, for instance. You can actually make use of the blockchain to track products to ensure they are probably well sealed, well packaged, or something like that, right? Then voting, I think that's very clear. You can make use of the blockchain in voting. Trying to maybe during an election, could be whatever form of election, could be any kind, political or not, right? So you can use it to vote because it's going to be transparent. Now, challenges of blockchain, energy use. When the blockchain network can use a lot of electricity, are we together? And that was very much popular with the proof of work algorithm, the proof of work consensus algorithm. Now, proof of stake does not consume as much electricity. It's not as if sometimes people make a mistake of thinking that the proof of stake consensus mechanism does not consume electricity. It does. It consumes electricity because you are making use of machines, you are making use of CPUs, right? So it consumes electricity. However, it does not consume as much electricity as the proof of work model, right? So running a blockchain actually consumes a lot of electricity. Now, scalability, I also talked about that. As more transactions or as more users are onboarded onto a blockchain, the slower it becomes. That is why one of the things through which we use within the Web3 ecosystem to solve the issue of scalability is the introduction of layer 2s. So layer 2s are basically side chains, they are para chains, right? That are created outside the main chain itself. For instance, Optimism, Arbitrum, and the likes. They are created outside the main chain itself. So they help to process the transactions, right? To take away, traffic from the main chain. So there will not be much congestion, on the blockchain. So as a blockchain grows, the slower it becomes. So you can't compare the way, how fast Ethereum was, let's say, in 2014 when it was created with now. It was way faster. Then if you sent a transaction, let's say in 2014, you got it instantly. And when new blockchain is created, that's the same way it works. Once you send the transaction, the recipient gets it immediately, right? But as people get on blockchain, it gets slower. So complexity, it still is relatively a new technology. At least it has not been up to 20 years. Research work has been going on blockchain technology for over 25 years. Since in the 90s, people have been researching what blockchain was all about and like that. However, the first practical application of blockchain was in 2008, 2009 with the introduction of Bitcoin. So it's relatively a new technology, and that's why this event has been organized, so that you can come to learn about the possibilities of blockchain technology and how we can access it, most especially as Africans, in building real-world solutions. Let's not build it's a challenge to us. Let's not build things that we don't need. Are we together? Yes, let's not build what we don't need. There are problems particular to the African ecosystem. There are problems particular that we see in day-to-day, in our data on blockchain technology for over 25 years. Since in the 90s, people have been researching what blockchain was all about and like that. However, the first practical application of blockchain was in 2008, 2009 with the introduction of Bitcoin. So it's relatively a new technology, and that's why this event has been organized, so that you can come to learn about the possibilities of blockchain technology and how we can access it, most especially as Africans, in building real-world solutions. Let's not build, it's a challenge to us, let's not build things that we don't need. Are we together? Are we together? Yes, let's not build what we don't need. There are problems particular to the African ecosystem. There are problems particular that we see in day-to-day, in our data on blockchain technology for over 25 years. Since in the 90s, people have been researching what blockchain, was all about and like that. However, the first practical application of blockchain was in 2008, 2009 with the introduction of Bitcoin. So it's relatively a new technology, and that's why this event has been organized, so that you can come to learn about the possibilities of blockchain technology and how we can access it, most especially as Africans, in building real-world solutions. Let's not build, it's a challenge to us, let's not build things that we don't need. Are we together? Are we together? Yes, let's not build what we don't need. There are problems particular to the African ecosystem. A blockchain is just a database. You can enter any form of data, whether it's a health record, you can enter records of students in a university. A university can actually make use of a blockchain. Do you get? So any record apart from financial records can be entered on the blockchain. So that's just it.
Thank you. Okay. Let's give one more question. Please come, and your question should not be longer than a sentence, a short sentence.
Thank you very much. Please, I want to ask this question. It's a bit practical. You talked about CPS, and from what you said, what I understood is, the more transaction in the blockchain, the more it becomes slower. But let's go practical now. Solana is actually 6,500 per second, and Ton is 107,000 per second. Now, we all know the volume on Solana and the volume on Ton. But if we, apart from the conjecture, like when it's okay, if I send Solana now, it's more faster than Ton. Can you explain that, that imbalance?
Okay, just hold on, please. Do you also have a data? Because for you to ask this, that means it's possible you have a data. Do you have a data of the transactions that are happening right now? And the only way to track that metric is if you have a data of the number of persons that are trying to send a transaction at this second on the Solana blockchain, and the number of persons that are trying to send a transaction at this second on the Solana blockchain. Again, it has to be for if you send it, there could be different things that could make that transaction not to go through immediately. For instance, if there were previous pending transactions, I don't know if you get me. Let's assume a particular block has been pending, let's say for the past 1 hour. If you send a transaction now, your transaction will not be processed except you are ready to pay very, very high, significant amount of gas fee. Do you understand? What makes transactions get processed very fast is even if I send a transaction now and my transaction is pending, right? Let's use one blockchain. Let's say Ton. Ton blockchain is currently congested. Am I right? Great. Now I have an EOA, that's an externally owned address with normal Trust Wallet, MetaMask, and co. Right? I send a transaction on that address, right? Maybe to somebody, and you also send a transaction. If my transaction was pending, right? And you try to send a transaction, we are still using the same Ton and the same blockchain, same wallet, everything. We are trying to send a transaction. Do you know if you pay a higher gas fee, your transaction will get processed before mine, even if there were previously other pending transactions? Do you understand? So that's what basically makes a transaction pending. It's not more or less like a comparison between the two blockchains. I don't know if you get what I'm saying. Or you want to add some more questions? Okay. So it's basically based on the priority fee that you send. If you send a higher fee, your transaction will be processed almost immediately. Do you understand? Okay. Like the gap in timing. Okay. Yeah. Yes. Okay. So please just what could also lead to that is there are several factors apart from the TPS, right? There are several other factors like the number of validators on the blockchain. Do you understand? In as much as Solana has 6,500 TPS and Ton blockchain has 100,000 something blockchain, The Solana blockchain might sometimes be faster than the Ton. Number one, I already mentioned one, if there are no previous pending transactions. Number two, the amount of fees that you used. Then number three, the number of validators on the, if the Solana blockchain, which has a TPS of 6,500, has a higher number of validators, let's assume there are 100,000 validators on Solana, right? And there are just 1,000 validators on what's it called, on Ton. In as much as Ton has the capability to be faster than Solana, since there are more validators on Solana, Solana is still going to be faster than Ton. So there are several factors that actually lead to that. All right.
Thank you very much. Please, a round of applause for Hezekiah.